Hello, yeah, in this video, I want to show you how to fit linear mixed models with the different correlation structures using the R package nlme. Okay. First, let's load in the library and then set random seed. Let's create a data set. And in particular, I create a data set with AR1 correlation structure and with binary dependent variable. And this is the data set. So if you want to take a look, and this is what it looks like. Okay. So x1 is a continuous variable, x2 is a categorical variable, y is a binary variable. And just keep in mind that the correlation structure is AR1. Okay. All right. To use the R package nlme, we can use it to fit a linear mixed effect model, and the function is lme. Okay. So very interestingly, if you remember back in LME4, we have a function glm I think. Yeah, we can fit generalized linear mixed model using the linear mixed model package. But here we can fit the linear mixed models using a package for nonlinear mixed models. Okay, so it's all messed up. Okay, so the functions LME and the syntax are very similar. You got the formula y tiered x1 plus x2, and then you specify a random intercept term, random equal tiered of 1, then subject. But then you also want to specify over time, you want a correlation structure. So the LMER function in the package LME0, LME4 is not very convenient for us to specify different correlation structures. Okay, but the LME function here is very flexible. So for example, if I want to fit a linear mixed model with random intercept, but also I want to fit a correlation for the AR1 structure, I can just use this syntax called the core AR1, AR capitalized, and then present form equal to tier.time. So this tells me the correlation over time is an AR1 structure, and it's nested within subject. Okay, then data equal to df and method equal to ml. So I choose the maximum likely estimation because later I want to do model selection by using AIC values. Okay, so and that's it. You can use this syntax to fit model linear mixed model with AR1 correlation structure. So this one is you want to specify the exchangeable correlation structure. The function is the core com-sim, so compound symmetry, okay, correlation structure. You can also specify unstructured. So this function is a core sim, so symmetric correlation matrix. So being symmetric is the only requirement. So it's unstructured. Okay, so you can do that. So you can fit 3 linear mixed models with the different correlation structures. And also we can specify different functional forms for the predictors. For example, we think maybe the relationship between x1 and y is a quadratic relationship. So we can create a x1 square by just square x1. Okay, and then we can fit 3 linear mixed models with x1 squared and x2 as predictors, and using AR1 exchangeable and unstructured correlation structures. So we can fit all these three models. And then we can do a model comparison by using the AIC value, okay? So it's very simple, just using AIC and parentheses, and you put all the models in there. And you get the model comparison, and you print it out. You can see there's 6 models we fit it, and the model with linear terms x1 plus x2 with an AR1 correlation structure has the smallest AIC value. So that's the model we should go for. And because we simulate the data set, we built in an AR1 correlation structure, and also the relation between y and x1, x2 are linear. So this model selection is accurate, okay? So by using these different models, I want to tell you that the AIC is very flexible. It can help us to select not only just the correlation structures, but also the different functional forms of the formula. Okay. All right, so this model is like an introduction to fitting linear mixed models using nlme package. Thank you.